Good morning, everyone. And guess what? Today is the 12th of January, and AQA has actually released the physics equation sheet. This is going to be for combined students and combined synergy as well. It has all the equations on there that you need to know for your exam. So, as you can see, obviously, it says a capital H and T, which is the higher tier. That would be more or less for separate physics, the equations that they would need to use. Okay, so do not get confused. These equations obviously will basically need to be rearranged as well, and you need to know how to rearrange them. But say, for example, you're given an exam question where you have to work out the density, and all you do is mass divided by volume. You don't need to rearrange it. But let's say, for example, you need to work out the change in speed, and there's your acceleration equation. So you can see that acceleration is a subject where it's the change in velocity divided by the time, but you need to work out the change in speed. So you need to know how to rearrange the equation, and this is what I'm going to talk you through. And if you watch my video till the end, I promise you that you will get full marks in your exam questions if you know how to rearrange the equation. So this is how the equation is going to be given to you in your exam. Delta V, a lot of students get confused with this, but I'm just going to make it very simple to you now. So that is just the final velocity, take away the initial velocity. So that's all it is, okay? So it's the change in speed, where it's the final velocity, take away the initial velocity, okay? So I will show you an example, because a lot of students do tend to get very confused about it. So let's just say the final velocity is 20, and obviously the initial velocity was 5. Just do 20, take away 5, and that's your change in speed, which is going to be 15. So I've just shown you this to make you understand and have a better understanding. So here is the acceleration equation, and we need to work out the change in speed. So what I need to do now, I'm going to go through how to do it. So we're going to times both sides by t, because we want to get the change in speed, which is a delta v on its own. So we just cancel it out, which you can see. So whatever we do on the right side, we do on the left side. Now we have the change in speed equals acceleration times by time. And I'm going to rewrite that again for you to understand it better, okay? So I'll just rewrite it for you again, which I'm going to do now very shortly, okay? And here we are. Change in speed equals acceleration times by time. And that is just so easy. And if you follow my method, I promise you will get those 3 to 4 marks. What if you have to work out the time? Now that is going to be a bit more different, because obviously it's the denominator. So what we need to do, obviously, we do need to get t on its own, but just follow the method and listen very carefully and use the technique. So what I'm going to do first, I'm going to times. The opposite of divide is going to be times. I'm going to times both sides by t, okay? And whatever you do on the right, you do on the left. I've times both sides by t. Now I'm going to cancel it out now, okay? So I'm going to cancel that out quickly. And here we go. But now, when I'm looking on the left side, I want to get t on its own. So I need to get rid of the acceleration. So that needs to go on the other side. So the opposite of multiply is going to be divide. So what I'm going to do now is I'm going to divide both sides by a, which is the acceleration. Okay? So I'll just show you there. I'm going to divide both sides by a. And then when I divide both sides by a, obviously I have to cancel it out, where you can see over here. And now I've got t on its own, so I'm going to rewrite the equation. So time equals change in speed divided by acceleration. I really hope my video has helped you, and I really hope it will help you towards your exams. And I hope, obviously, you do really well. All right, thank you. Bye.